Hello and welcome to Otten Math. We're going to have 3 videos, and each of these 3 videos is going to work on helping you to graph quadratic functions in the different forms that they come in. First one's going to be standard form, second vertex form, and the third is intercept form. So what is the standard form of a quadratic function? Well, it looks like this. ax squared plus bx plus c. So there's a value a, there's a value b, and there's a value c. Remember, the requirement for a quadratic is that a has to be something other than 0. So let's take a look at how to graph a quadratic in standard form. We're going to go through this step by step. Now, just to let you know, for each of the different forms, we basically end up with the same values, but we approach them or accomplish them in different orders. So the first step in graphing a quadratic in standard form, and I give you the example, negative 3x squared minus 12x plus 1, is to find the axis of symmetry. And simply the axis of symmetry is going to be x is equal to negative b over 2a. Now a lot of students will just say negative b over 2a, but that just gives us a value. It doesn't give us the equation of a line. And that's what we're looking for. And remember, the axis of symmetry is that line that divides the parabola into 2 equal halves. So if I put in the values for negative b, so I have negative b, which is going to be negative or minus 12, so I have minus 12 over 2a, which is 2 times negative 3, 2 times negative 3, and I end up with positive 12 over negative 6. So that's the value that we have listed here. X is equal to 12 over negative 6, which is the same as x is equal to negative 2. So I'm going to go to my graph, and I'm going to go ahead and graph x is equal to negative 2. So x is equal to something is just going to be a vertical line. Remember, this is the axis of symmetry. It divides the parabola into 2 symmetrical or equal halves. Okay, so I have my axis of symmetry. That's the first step. Second step is to find the vertex. Well, we know that the axis of symmetry, which I abbreviate as AOS, goes right through the vertex. So the axis of symmetry is going to provide us with the x-coordinate or value for the vertex. And we're going to use this x value from the axis of symmetry to find the y-coordinate by plugging it into the quadratic and then solving for y. Okay, so we learned that the axis of symmetry is x is equal to negative 2. So the vertex lies on the axis of symmetry. Now we're going to plug in negative 2 in for x. So I have negative 3, so I have negative 3 from the quadratic, times negative 2, which was x, squared, minus 12 times x, or negative 2, plus 1. So now I have, I use PEMDAS, so I'm going to tackle my exponents first. Negative 3 times 4 plus 24 plus 1. I have minus 12 times minus 2 is plus 24. And I end up with negative 12 plus 25. Y is equal to 13. So the vertex is going to be negative 2, 3. So I go ahead back to my graph and I plot the vertex, negative 2, 13. So negative 2, 13 is now my vertex on the axis of symmetry. Remember, axis of symmetry runs right through the vertex. And now I'm going to move on to step 3. Okay, step 3, I'm going to determine the y-intercept. That's a very easy process in standard form. Not always the case in vertex form or in intercept form. But in standard form, all I have to do is look to the c value. Right? Look to the c value. There's my c value. There's my y-intercept. My y-intercept is 0, c, or in this case, it's going to be 0, 1. Now, why is that the case? Well, the y-intercept is the location on the graph where x is equal to 0. So when x is equal to 0, I'm somewhere on the y-intercept. So all I need to do really is to set x equal to 0. And you can see that the result is just going to be c. I have negative 3 times 0 minus 12 times 0. That equals positive 1. So my y-intercept is going to be positive 1. So let's go back to our graph and we're going to plot the y-intercept. So I plot the y-intercept now. It's at 0, 1. All right, step number 4 is I'm going to find the x-intercepts by factoring the equation or using the quadratic formula and setting y equal to 0. So the graph crosses the y-axis when y now is equal to 0. So I'd want to rewrite the equation as negative 3x squared minus 12x plus 1 is equal to 0. Now we can go through our diamond and box process. We'd find the factors of -3 that add to -12. But we'd realize quickly that this is not an easily factorable quadratic. So we'd move on to the quadratic formula to solve. And the quadratic formula is a topic of discussion for some other time. But we find the x-intercepts at 0.080, 0.08, comma 0, and -4.80. So moving on to our graph, we're going to plot those two graphs. And that's just the location, again, where the parabola crosses the x-axis. So now I have my vertex, my y-intercept, and my two x-intercepts. What do I have left to do? Okay, last step is to determine if the graph opens up or down. This should be pretty apparent once you have the vertex and the x-intercepts, but we'll just go through the process again. Now, if the sign in front of the a value is negative, then the graph is going to open down. I call this a sad parabola. So if it's negative, it's unhappy, the graph opens down. So it's going to look something like this, right? Unhappy parabola. And if it opens up, or if it's positive, it opens up, it's going to be a happy parabola. All right, so we know that the a value in terms of this particular quadratic that we've listed is negative, so it's going to face down. And then we're just going to go ahead and finish graphing the quadratic. We have everything that we need. So I have my axis of symmetry, x is equal to -2, runs right through the parabola. I have my vertex, -2, 13. My y-intercept, 0, 1. My two x-intercepts, -4.8, 4.080 and 0.080. And I know that the graph faces down.